right, this is a calculus practice exam. This is pretty much what you should expect the test to look like, given a few changes. I'm going to go through the whole thing, explain everything best I can. Hopefully my camera work isn't awful. It probably will be. But let's see. Problem one. For this function graphed right here, we have ourselves a piecewise function that seems to be trailing from the left, goes to 1, 1, and then all of a sudden changes, starts, but doesn't have a closed dot at what looks like 1, 4, and then goes to the right. So let's answer these questions. The limit as x approaches 1 plus means 1 from the right. So as we move from the right, my dot here at 1, 4 shows my limit. So my limit is going to be 4, okay? B over here, this is saying x to the negative 1 is asking what's my limit as it's coming from the left. So as my graph is coming from the left, it approaches 1 right here at 1, 1, 1. Now this is saying what's the limit as x approaches 1, period. No direction given. A limit only exists if the left side and the right side match up. In these cases, or in this case rather, they don't, so the limit does not exist because the left and the right do not match up. This is asking what happens as the limit approaches infinity, positive infinity. I really didn't give a good picture for this. I kind of had it trailing off here. I kind of forgot this as I made the picture. So we're just going to say like 2.5. It looks like that's just going to stay straight. We'll just make believe. But, you know, keep in mind if this were to go all the way up, that would be infinity, or go all the way down, that would be infinity. But I'm just going to make believe that that's still moving to the right. So we'll say 2.5-ish. That's a bad problem, a bad job by me. F of 1 means if I were to plug in 1, what would I get? Since the circle here is filled in at 1, it will be 1. And is f continuous at 1? Nope, because it stops and then starts over somewhere else, so the answer to that is no. Speaking of continuity, we have the second problem here. I'm asking you if first this guy, which is another piecewise function, if it's continuous from definitely 1 to definitely 3. This is definitely 1. It starts and then at 2, it breaks off into something else, so that is a big no. This guy, on the other hand, is saying starting at 1 but definitely 1 and ending at 2 but not exactly 2, is it continuous? In this case, yes, because this is saying closed interval means the dot. As it goes to 2 but not hits 2 but goes to 2, is it continuous? And in this case, yes it is, because that indicates, the parentheses indicates an open interval, whereas the bracket indicates a closed interval. Okay? Page 1, donezo. All right, page 2, we're starting out with a limit algebraically. This guy right here is asking me to find the limit as x approaches 1 of x squared minus 1 over x minus 1. As you can see, plugging in 1 on the bottom would make the whole thing explode, so we have to try a different route. So what I'm going to do is I'm going to use difference of squares to factor out the top. Difference of squares is when you have a square minus a square. In this case, x squared is a square minus 1, which is also a square. If I factor that out, that factors out to that. Oh boy. Let's see how long that lasts. I'll be right back. And we're back, and I have a marker this time. As you factor out the top, you get x plus 1 times x minus 1. Leaving the bottom as x minus 1 would have you cancel that out. So if I have the limit as x approaches 1 of that guy now, I would say the limit as x approaches 1 of x plus 1 means I could just plug in 1. 1 plus 1 is 2. Donezo. This guy is a little more complicated. I can't just plug in infinity. That doesn't make sense. You could factor, I guess, but factoring that is a huge mess. So what I would do is I would notice the fact that you have a power of 4 over another power of 4. When you have that, you have one of two options. You can multiply the top and the bottom by the reciprocal of the highest power of the denominator. What that would look like is I would have to multiply the top and the bottom by 1 over x to the 4th over 1 over x to the fourth, and that'll make a whole lot of things go away. But since we're approaching infinity, what I can do is this little rule that you had in your notes, the end behavior, and remember you get end behavior when you deal with infinity, the end behavior of a rational function matches the end behavior of the quotient of the highest degree term in the numerator divided by the highest degree term in the denominator. So since I'm going to infinity, I care about the end behavior of the highest degree in the numerator, which is that guy right there, divided by the highest degree in that. In other words, 2 over 5. And that's literally going to be my answer when I'm done. 2 divided by 5 is 2/5. All right, problem 3. I gave up on the marker, so I'm back to the old tried and true pencil. This is asking us to find the derivative using the old-fashioned form that I gave you. When you're finding the derivative using this method, there's 2 things that you really have to do first. First, find out what f of x plus h is, and then remember what f of x is. Subtract a bunch of h's should eliminate, and then you should be able to plug in 0 willy-nilly just fine. So this is what I need to do. There's my f of x. What I need to do first is find out what f of x plus h is. So finding f of x plus h means taking the x in f of x and replacing every x with x plus h. So f of x plus h is going to be x plus h squared plus 2x plus h. Okay? Going the long way and not using any shortcuts, x plus h squared is the same thing as saying x plus h times x plus h. Okay, it's not x squared plus h squared. So I'm going to write that out. Now you FOIL x squared plus xh plus xh again, because of that, plus h squared ends that part. Okay? Distribute again, plus 2x plus 2h. Combine like terms here gets me x squared plus 2xh plus h squared plus 2x plus 2h. That is f of x plus h. So now that I have f of x plus h, and I know what f of x is, I can throw it all in. So f prime is going to be the limit as h approaches 0 of f of x plus h, so let me write it all out, h or x squared plus 2xh plus h squared plus 2x plus 2h minus f of x, which is x squared plus 2x, so minus x squared plus 2x, all over h. It's really hard drawing a long line when you only have one hand. My apologies to all of you one-handers out there. Hopefully none of you I teach. Drop the first parentheses, it's not needed, so let me just write out x squared plus 2xh plus h squared plus 2x plus 2h. Distribute the negative, minus x squared minus 2x. Here's my long, terrible line again. Let's see what eliminates. Okay, x squared minus x squared, 2x minus 2x, that all goes away. And this is what I'm going to be left with. So I'm going to kill 2 birds with 1 stone here because I'm running out of room. I have a 2xh plus h squared plus 2h left. I'm going to bring out the h first. Okay, I'm going to factor that out. So that leaves me with 2x, no more h. Bringing 1h out of an h squared is regular h, because h times h is h squared. Bringing an h out of 2h is 2, all over h. Cross that out. Now what I'm left with is the limit as h approaches 0 of 2x plus h plus 2. Plugging in 0 eliminates the h, and I'm left with 2x plus 2. Sorry for the bad camera work. So once you have that, You can look at your original problem, and if you know the shortcut, you know that's right. So that's the second page. Done. All right, calculate the derivative of the following functions. We're going to do this one problem at a time. So nothing fun about the first one right here, right off the bat. We have some craziness already happening, but no big deal. I'm going to rewrite this as 5x to the third, nothing changes there, minus x to the 1/3 plus 3. Okay, taking the derivative of this first guy means you bring out the 3, multiply it to that 5, and get 15. X to the third drops down to x squared. The second guy, the negative is still there, bring out the 1/3, take away 1 from 1/3, and that's negative 2/3. Remember, 1/3 minus 1 is not negative 1/3, it's negative 2/3. We'll change that in a second. Taking the derivative of a constant, a 3 in this case, just makes it disappear. So one last thing before I call it a day. Okay, I'm not a big fan of the way that second one's written. The first one, fine. The second one, if it's a negative exponent, drop it to the bottom. So 1/3 has an x to the 2/3 hanging out. I'm going to make that cube root of x squared. Okay, hard to see, but that is now saying 1/3 times the cube root of x squared. If you wrote out 1/3 to the x times x to the 2/3, I'd let it go. I'm just not a fan of negative exponents. That's why I brought it down there. All right, B, f of x equals cotangent x squared. We have ourselves a function within a function, so that's going to involve chain rule. Remember the way chain rule works is you take the derivative of the outside, and the derivative of cotangent is negative cosecant squared keep the inside and multiply everything by the derivative of the inside. So I'm just going to rewrite this. Bring that keep that negative out there, move the 2x to the front, cosecant squared x squared. All right, problem C, it looks like we're gonna have a quotient rule, and then while doing quotient rule, we're gonna have chain rule involved. So that's my U, that's my V. U prime is going to be chain rule because I have a 2x inside a cosine. So function within a function means I take the derivative of the outside. The derivative of cosine is negative sine. Keep the inside, so 2x, and then multiply everything by the derivative of the inside, so that's going to be 2. So let me do this. Let me make that negative 2 sine 2x. So again, the derivative of the top is you take the derivative of the outside, so the derivative of cosine is negative sine, keep the inside, multiply everything by the derivative of the inside, which is 2, and so I snuck that 2 there. V prime is just 5. And then V squared, because it's quotient rule, is going to be 5x minus 6 squared, and let's see if we're going to have to change that. Okay, F prime is going to be U prime V, so U prime is that ugly guy right there, negative 2 sine 2x times, oh wait, that's U prime, V is 5x minus 6 minus V prime, which is 5 times U, which is cos 2x all over V squared, which is 5x minus 6 squared. I'm going to leave it like that, and I'd accept that happily because there's really not much I can do. I mean, I can distribute the 5x that whole thing and the negative 6 that whole thing, and nothing would happen, nothing will disappear, nothing will go away. So I'm leaving that the way it is. All right, D, there's two ways that I can approach D. I could do quotient rule, and then while doing quotient rule, I can, do, I guess, chain rule for this one. But I'm just going to do the chain rule, and this is how I'm going to do it. I'm going to rewrite this as, first off, I'm going to do it in a two-step process, just so you can all see it. I'm going to rewrite the entire bottom as 2x squared plus 1 to the 1/2, and then bring that up and make it 2x squared plus 1 to the -1/2. I'm going to do chain rule on that guy right there. So remember the way chain rule works. Take the derivative of the outside. The outside is to the -1/2. So the derivative of the outside is -1/2. Okay, that drops down to -3/2. And if you're wondering, well, where did he get that from? The -3/2 is when I take away 1 from -1/2. So if I have -1/2 minus 1 is -3/2. So the derivative of the outside looks like that. Keep the inside and multiply everything by the derivative of the inside. So the derivative of the inside is going to be 4x. Okay, drop down the 2, keep the x, that goes away. And when I simplify this, that 4 and that -1/2 becomes -2. So I have -2x, 2x squared plus 1 to the -3/2. I hate the way this looks, so I'm going to write it out like this. Okay, and bear with me. -2x over 2 means the square root of 2x squared plus 1 cubed. All right, so if you're wondering what I did there, negative means I dropped to the bottom, over 2 means I square root it, and the 3 on the top means I have everything cubed. I think that should do it for that one. What a mess. All right, what I'm doing with 5 is I'm being asked to not only take the derivative, but then when I'm done, plug in 1. So I'm going to do the derivative by doing quotient rule, and then while doing quotient rule, it looks like I'm probably going to have to do chain rule. So I'm just going to write it all out because I really don't have a whole lot of room. U is the top, which is 2x plus 1 squared. V is the bottom, which is 3x. U prime involves the chain rule, which means take the derivative of the outside. The outside is 2, so you bring out the 2. That 2 over here drops down to a 1, so I'm going to have invisible 1. Keep the inside and multiply the whole thing by the derivative of the inside, which is 2. So rather than write out times 2, I'm just going to say 2 times 2 makes that a 4. And I'll probably end up distributing that if I ever have to. V prime is 3. V squared is going to be 3x times 3x. So 3 times 3 is 9, and x times x is x squared. And I put it all together. F prime of x is u prime v. So let me distribute this now. U prime v is going to be 8x plus 4. That's my u prime, 8x plus 4. V, so I'll distribute again, probably, minus v prime u all over v squared. Okay, now if you left it like that, I'd be okay, but technically I'm not asking for the derivative. I'm asking for what happens when I take the derivative and then plug in 1. So my answer is not me looking for that or even a simplified version of that. It's me finding the number after I plug in 1 for x. So let me do that. F prime of 1 equals 8 times 1, which is 8, plus 4. 3 times 1, which is 3, minus 3 2 times 1, which is 2, plus 1 squared, all over 9 times 1 squared, which is 9 times 1. 8 plus 4 is 12, times 3 is 36. 2 plus 1 is 3. 3 squared is 9, minus 3 is 27, times negative 3 is negative 27 over 9. 36 minus 27 is 9. 9 over 9 is 1. Ugh. B is the same as it was last time. Looks like chain rule. F prime of x is going to be take the derivative of the outside, which is cosine, keep the inside, but multiply everything by the derivative of the inside. Okay? So in other words, 2 cos 2x. What I have to do here is I have to plug in pi over 2. So I have f prime of pi over 2 is going to be 2 cos 2 times pi over 2. 2 times pi over 2 is just pi. So 2 cos pi is negative 2. Not so bad. All right, last problem. If you're wondering if I'm resting my phone on top of a bottle of Kombucha that I got, you're absolutely right. I paid $6 for this thing, so I'm going to put it to good use. All right, last one. If y equals x squared cos x, find the double prime. So not only am I finding one derivative, I'm finding a second derivative. So here we go. Single derivative, that's my u, that's my v. So u prime is going to be 2x. V prime is going to be negative sine x. So y prime, using the product rule, is going to be u prime v, in other words, 2x cos x, plus v prime u. So negative sine x times x squared. So what I'm going to do is I'm going to make that plus a minus, and I'm going to put that x squared first because it's proper. That's the first derivative. Now the second derivative involves me taking each part here and finding out the product rule of each. All right, so let me do this part first. I'll call you u and I'll call you v. So u prime, so I'm going to use product rule twice if I haven't said that yet. U prime is going to be 2. V prime is going to be negative sine x again. So u prime v is going to be 2 cos x plus v prime u is going to be negative sine x times 2x. So I'm going to do what I did last time and throw the negative out here. 2x sine x. All right. Now I have minus x squared, so I'm just going to let u be the negative. So u is negative x squared, v is sine x, u prime is going to be negative 2x, v prime is going to be cos x. Okay, so I have a plus sign here. So since I made that part of it, I'm adding everything. V prime u is actually going to make that a negative. V prime u is negative x squared cos x plus u prime v. I just realized I did that backwards, but with product rule, it doesn't really matter. But you know now. Minus 2x sine x. Oh, that would have been so nice if they could have canceled out. But they didn't. So y double prime. See if that'll work. Nope. U double prime, or y double prime, is going to be that whole thing combined. I have 2 cos x. I have negative 2x sine x minus 2x sine x, which is negative 4x sine x minus x squared. Oh my gosh. X squared cos x. All right. So again, what I did is this is my original problem. Product rule. Got a derivative. In finding the derivative, I had to do the product rule twice. Okay, u prime became 2 and v prime became negative sine x, blah, 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 blah. Put it all together. These guys combined got me that guy right there. All right, that should do it. Have fun.